Hello, everybody. Welcome. It is the 18th of October for Dallas Personal Robotics Group. Get together online and go around the table. Just as a reminder, this meeting is free to attend. Everyone's welcome. DPRG membership is not required, but we do. You can find out about them here at this link. And then for regulars, we do have membership fees that help us cover costs, but they're not required to jump in on this meeting necessarily. So we'll do the usual and go around the table tonight. We have a short queue at the moment, and hopefully it'll fill up in a little bit. We've got John, and then Michael, and then Doug, and then open mic. So John, what do you have?
Okay, well, you can see my second Halloween skull face behind me there. I finished that, tested it. I've got some slight changes and some more audio that I've added here. So let me go ahead and share. Present screen. Hopefully you'll get the audio with this. Okay, here we go. Can you see this?
Yep.
You can see the eyes moving independently of each other.
It's awesome.
Yeah, pretty good.
And if you get close, he bites you.
Did you 3D print the skull itself?
Yeah. Yeah, I found a 3D design. The design that I used, that I found on the web, is actually it's like something like a 20-something piece model of a full-scale model of a skull that you attach with magnets. It's got little places that you put magnets. What I did was I took all those STL files and selected some of the STLs and merged them together in the Prusa slicer, so that I get just the front portion of the skull and the jaw. So
pretty good.
This other build that I found, it's a Lego powered submarine with automatic depth control. It's going to run by a Raspberry Pi. And it uses this cylinder here for the ballast to make it dive and climb. So I'm gonna try to show selected portions of the build here. He uses Lego to operate the ballast, the syringe. And let's see. Here he builds the hull. And he uses a magnetic coupling here to drive the propeller. So they didn't have to cut holes in the hull. He's using a Pi Zero to power it. So here's a more completed version of the build where he's testing it out.
Okay, once he empties the ballast, though, doesn't he sink to the bottom?
And here's a test. And what he's doing is he's got a little hole in the front. You can see where he's pumping the water in and out of the ballast.
But is he displacing air?
Yeah, he's displacing air, and he pulls water into that syringe. It's operated with this little Lego motor.
I think the air is going to be the same.
He actually took it out, put it in a stream and navigated around the stream here.
He's got a little man in there too.
Yeah.
Gotta have a captain, you know.
Yep. Somebody's got to run the thing.
And he looks like he's got various sensors on there for temperature. And I'm not sure what he's doing with a laser. Somehow he's using the laser to control depth, I think. Or maybe he's doing some range finding on it or something. Anyway, that's it. So a pretty cute
pretty
build.
cool.
I'll let me get the link. If anybody wants to watch the whole thing, I'll post the link in chat.
Wonder how the Colombians do it.
Hey, John, is it tethered?
No, not tethered at all. It's completely completely remote. I'm not exactly. I think what he's using the Raspberry Pi Wi-Fi most likely to control it.
Wi-Fi even reach down into the water? I'm surprised.
Yeah, I didn't think so. I don't know though. Never tried it.
Me neither.
Anyway, if you're interested in some of the details, there's the link.
Okay, cool.
Posted in
That's-
chat.
Definitely somebody's got a neat project there.
Very nice find. Thanks.
And then my skull face demo. That's the other link there.
Okay, cool.
All right, Carl, it's all yours.
Good job. All right. Excellent.
Yeah, good job.
Okay, so next we have Michael. What do you got going on?
Okay. You know, I told you I was wanting to get these TT motors to run in a straight line, and Doug said I could do it. So it was doable. So I want to demonstrate that I got this. I'm going to have it do a figure L. Go over there a couple of feet and then hang a left. And of course, this will be the time it doesn't do it. But let me get my camera over there. I guess I could present, huh?
They never work when you want them to.
I know. Let's see. Let me do the presentation deal. What's going on here? You know, what am I doing wrong here, folks? There we are. Y'all see that?
Yeah.
Y'all see that?
Yeah.
I'm trying to put my little. All right, here goes. Not the best. Let me just hold this thing. Let me see here. Okay, there's my robot.
Well, that's a pretty. Look at that.
Oh, very nice.
It did pretty good for those cheapo motors. So
Gold star.
yeah, thank you. So it's got, you know, I got a little tweaking to do with it, but it's not very. Sometimes it doesn't act right. Sometimes it does.
So how are you controlling the motor? Just by what power supply to them?
Encoders. Those little encoders on here. And then
How do you
You
use
stand
them?
on
Good loop.
Oh, okay.
those are those little encoders.
Okay.
I got these little motors from Mauser. I bought these bills from Adafruit, you know, so that made it run a lot better, putting some decent wheels on there. So anyway, I just got a regular old, what is that, L298 or whatever that is. And I'm using a modified version of code I got off of SparkFun that just goes in a straight line. This is the same code I used in the competition here a few weeks ago. But these little motors are running in a straight line, so I actually feel, I made some accomplishment there.
Did you say you got the motors from Mouser?
Yeah.
I didn't think they sold motors.
They sell Adafruit. They sell Spark Fun. They sell DF robot stuff. And I live 10 minutes from Mouser, so it makes it easy. I can do a wheel call and order some things for me.
I thought they closed the will call window and had not yet reopened it. Am I wrong?
No, because I bought these just a few weeks ago. When did they close it? At COVID?
Yeah, they closed it for COVID, and I'd not seen any indication that they had reopened it. How recently did you went just recently to a will call window?
Yeah. What date is this? June 14th.
Oh, okay, cool. Because I live about 15 minutes from them, and I used to use the
Yeah.
will call window until they closed it.
I live over here in Kennendale. I don't know if you know where that's at, but they come in that little package right there.
Yeah, and it kind of sucks that their only delivery option is UPS for $8.
Yeah, but when I ride over there, it's kind of like, it's kind of neat. And they have some items. I was looking at one of Adafruit's driver motor shields, motor driver shields today that Adafruit doesn't have in stock, but Mouser has about 20 of them. So that's kind of cool.
Yep.
All right, but anyway, I made that. I made those cheap motors go in a straight line. So happy about that.
Nailed it. Were you using a loop of any kind, control loop, or just whatever was in that Spark Fun code?
Well, I had to modify that SparkFun code because I had to add some my own functions, to hang a left. And yeah, I had to chop it up pretty good to get it to so when you want it to hang a left or a right, you got to comment out some lines and write some extra. I had to write some extra. I had to write some extra code. What's the word I'm looking for? Variables. I had to write my own variables to work with the code.
Well, good.
So,
Very nice.
but the thing about it is that he doesn't write that code he doesn't separate each motor independently. In the code to where you can kind of like, if you wanted to tweak one motor a little faster by itself, it won't work like that. It's kind of, I don't know how he does it, but he did a good job. So it's all right. I'm done there, I guess.
Way to go. Gold star. That takes us to Doug. I think you're next. And then we have an open mic after you. Uh-oh, muted.
You're muted.
We have a closed mic for Doug.
Yeah.
Before I get started on the Robo Columbus thing, let me, I wanted to share this. It just came out today. Whoops. I guess you can't see that. Give me a second here. Okay. Yeah. This just came out. It's reasonably priced.
Channel.
Yeah,
Yep.
8-channel. And where this would really come useful for us is if you're using some of those LiDAR ST micro,
Multiple. Yeah.
VLs, whatever they are. This would work really good with that, and the price is reasonable. You have to add shipping, and cables, and I don't know if they are compatible with that particular system, but they probably sell the module. They probably sell the module too, so you could probably get it from them. But anyway, I just thought that's Adafruit does a good job in kind of like hitting what you really need.
Mm-hmm.
All right, so let's see here.
Yeah, I saw that in an email today.
Yeah. Okay. So I'm going to show a couple of videos, and actually, I was going to show another one. Why is it not in there? Wait a second. No. Videos. Okay. Let's see if this. So what I'm doing here is this is in my yard, and this distance is not really that big. I want to say it's maybe 50 feet. I don't even, probably not even that. Now, the steering is under robot control, but the turning the wheels, I'm controlling them because I don't have my emergency stop set up yet. You can see it's wandering around, but that's because the cone, or where it thinks the cone is actually moving around as additional GPS locations happen. But it did steer to the cone. It was pretty good. Now the next question you have to ask is, all right, that's cool, but what about you got to have the second part, which is in the world. Is so in this one, I'm just trying to see where. So here, both steering and power is being controlled by me, because what I'm trying to do here is. Wait a minute, hold on. I think this is the same one we just did. Okay, so I did have it.
Looks like it's moving pretty fast.
This one is, remember, this is me. The steering is under robot control, and I'm actually doing the power. So where it was safe, i.e., not going to hit the wall, fence, or other stuff, I would speed it up. All right. So what happened to it? It wasn't a VCC. Well, I guess it was this. All right.
Oh no, what happened?
Yeah. Okay. Well, we'll go. I can't even find the same the directory I was in. Okay, let's go back to here. All right. Well, let's see if I can figure out which one this one is. Okay, this is a similar run to the one you just saw, but it's from using the VNC. And you can see in this run, it went the other direction. And you can see I'm slowing it down because I wasn't sure it was going to run up there or not. And I'm not getting 100% capture on the VNC. But if you look over in this section, what it's telling you is it's telling me that the GPS, no, excuse me. This one's telling me that it's had a 65% confidence of this. And this was the pixel. Otherwise, what it was doing is it's taking this from here to here, and it's trying to say, well, where in there it is, the center point is, and trying to adjust an angle. So this is actually an angle. It's actually saying the center is at 125 degrees, and that's what the servo would try to would feed back to the steering. So, but it's not, that loop hasn't been finished because I'm working on the serial port software now. Okay, and there was another one I wanted to show you guys to show how it was the VNs. I don't know. Did I lose them all? Oh no, somehow I got put in here. Let's see if I can find the right video. I think it's this one. Okay, and this one, if it's the right one, I'm driving it, but I'm trying to get it to see cone as much as possible. So this is me driving it, and if it's the right one, I'll back up here in a minute. And what I'm just trying to do is see if it's, how well is it doing the capturing. So I'm just, there it is again, you know. And I believe when you see the square or not on the cone, what's going on is my video is lagging. So what I'm getting at is, I think what I'm seeing, or my experience so far has been, that it's doing a really good job of detecting the cone. And now this is not as challenging as light as that one before. But even when it gets kind of like a crappy scene, like here you can see that video is really lagged out, it'll still find the cone. So if I can point it at it. Now, remember I was telling you that I had problems with the suspension. So I stiffened up the real suspension really, really stiff. And now it's bouncy. So I got to figure out, tune that up a little bit.
Got to add a dash pot shock absorber.
Well, it's got the shock absorber, but I've probably got the springs tied up. You know, I got them like maxed. So anyway, those are the 3 videos. And so what did we show? One, we can show that the Raspberry Pi with the light, Oak D light, is finding the cone, and the model is reasonably good. We can see that the steering, which is using basically the GPS reading, distance. Otherwise, you know, when you get to GPS reading and you have a target or a waypoint, on when you have a waypoint. So so you have a waypoint, you have the GPS that can tell you the distance to the waypoint. So, and you also can get the heading to the waypoint. So what I have done is, right now, simplistically, is I'm using the GPS heading to the waypoint and the IMU magnetometer 9-degree fusion heading that the robot's in. So if the robot's turned this way and it tells me the cone is over here, the robot should turn and cause the distance to decrease. And I actually have that on video, but it's pretty boring. You know, it's just a bunch of numbers running by that tells you that it's getting closer. So that seems to be working. Now, the problem you have is that when you're close to the cone appears to move around because the GPS, you know, is plus or minus 5 or 10 feet or whatever it is, even on a good one. And it can be as far as 20 feet. So, or is it 20 yards? I think it's 20 feet.
It's like
No?
a 20
yards, I think.
20-foot diameter, 10-foot radius, supposedly.
Yeah. Okay, so that could be, so while you're aiming at it, as you're going to it, and the GPS is updating, you know, it's jumping around. Now that's a problem when you're close. Now, if you got 100 yards to go, it's not a problem because it's way down the field and you're just running towards it. So, and it looks like the cone can be detected by the OD light pretty far away. And so I'm pretty sure now. So the only thing I've got to do, I'm working on the serial stuff to actually bring it into my tiny 3.2. And I'm about 80% done. I just haven't done that yet. Today I spent, since I wanted to get it running on both steering and power, I wanted to get the safety switch finished. And I finished that before the meeting. So that's kind of cool. It's the way I've done that. Give me a second. I'm using a pistol grip like this. Well, if you know on the pistol grip, if you have 3 channels, one of them is steering, 2 is throttle, and 3 is an auxiliary. And you can use the auxiliary. That's this button right on the side here. Right, I'm pushing it with my thumb. You can use that, but it's kind of awkward. Okay, because you know how it is. I'm hitting the wall. I'm hitting the wall. I'm hitting the wall. Push the button. Push the button. Hitting the wall. Hitting the wall. Smack. Push the button. You know, it's not really the ideal thing. So what I've done is I've moved it to the throttle, because there you either push it or you pull it. You do something. You know what I mean? The biggest problem with this one is that you might be oversensitive. So what I've done is I've set a band, and it turns out that because of the way RC works, there's always a signal on channel 2 that's equal to neutral. All right. That way, otherwise, when your throttle, if you think about it, if something goes wrong, it just drops to neutral. You can turn the controller off, and it'll go to neutral, and your car will just stop. That's a safety feature. Well, I'm using that for so what I've done is I've said if the signal is greater than 1.75 or less than 1.25 milliseconds, that means either you went like that or you went like this, then it engages the safety switch. So that's working out really well. And so I'm pretty happy with that one. In the past, I'd used the auxiliary channel, but like I said, you know, you get in a panic of the moment, pushing this little recessed button on the side, it's scary. And I've also put, so like I said, now it's twitchy because you could go just a little bit like that, and it would cause the thing to engage. But what I've done to do that is I've actually put a leaky integrator on it, so that you got to hold it for about a half a second before it engages. And I can adjust that as I get more information, but that's a half second seems to be pretty reasonable. So anyway, got the safety done. And like I say, I've completed this. I've completed the throttle software, but I didn't want to engage it until I had the safety switch done. So, but I'm thinking that part's done. So now I got to get the serial work from the Raspberry Pi to the Teensy, and that way it'll get the update of when it sees a cone. And so on the Raspberry Pi, all it'll be doing is saying, I see a cone and it's where the center is to the left or the center is to the right, and adjust the steering. So what I see in the program is you're using your loop for GPS and IMU. You're using that until you see a cone. Then it switches and then it goes to the cone and goes through the end game. And then obviously it's got to back out and re-switch when you go to cone 2. But it's getting there, guys. I think I can make it. So there we go. That's all I got to say.
Hey, gold star progress. Who can argue with that, huh?
Yeah, I get a gold star for that.
Yeah. So, okay, well, that was our previously queued things. So, does anyone have some stuff to put in the open mic part?
I wanted to ask Michael if the SparkFun code he used was the Redbot code. Is that what you used, Michael?
It's called Fredbot. I put a link in the messages.
Oh, okay, I'll look for it. Oh, there it is.
Yeah, just click it. It's called. I got it off of one of those YouTube tutorial kind of things that they do. Off of YouTube.
Yeah, I think I recognize it.
Yeah, and so I modified it somewhat to.
All right, thanks.
Yeah, at a glance, it looks like a pretty straight proportional control, right? So
it's just proportional. There's no added libraries or anything to it.
well, I mean, proportional is the math, so it's just a function of the error from the last loop iteration.
Yes, is that what? Have you seen it?
Yeah,
Yeah,
take a look. Yeah.
Yeah.
So that's proportional. Without, I guess that's all there is to it.
Yeah,
Pretty
so the
simple.
correction is proportional to the most recent error.
Right. So that's how it's working.
It's amazing. Almost any type of time you write code, that you control something, you probably inadvertently at least using a proportional controller. You might not call it that, but essentially you're using the input times some fudge factor and it's equaling an output. That's a proportional controller. So, it's kind of cool.
So I'm so new at this stuff. I don't, I just grabbed it, it worked, and I did figure out how to edit it enough to chop it up enough to get it to turn corners for me.
Yeah, good way to start and learn.
It is.
Yeah, it's been learning for sure.
Michael, this sounds like me in Python.
Well, see, for somebody who doesn't do this for a living, or just a lot of this stuff, it'll just overwhelm a guy looking at this stuff, and but take it a little bit at a time. I've been studying this code ever since, off and on. Still, just trying to figure out what all that. It's all related to each other. All those variables are attached to the other variable
Well, I'll tell you, you're lucky. 30 years ago, we were doing this in assembly language.
Yeah.
That was ugly.
Yeah, I'd have never made it. I'm glad I'm kind of getting, it's just for dummies here. So I'll get right in. So.
It makes me wonder. So we have a language called C, which is the name apparently given to the quality of the language. So it makes me wonder why we don't have a language called gibberish, because that's what it is anyhow. What's your robot written in?
Gibberish. It's all Greek to a lot of people, that's for sure.
Yeah.
And I'm kind of surprised at how, and I've told y'all guys this before, the lack of straight line code that's out there on the internet that a guy can just grab and maybe, tweak it to what he needs to do, and the lack of it out there. So that I've found. Maybe if a guy knows how to hunt on GitHub better than I do, I don't know.
Software is plumbing these days, right? You just grab the pieces and plumb them together, and maybe it works.
I just Google till I run into something is what I do.
Yeah, nowadays we have computers that have tons of memory, so you tend to get rated code. I have something I can show. I found that
What's up,
might
John?
be of interest. I'll click and see what we can. So there's two things. First thing off bat is in case you need bigger. If you need a
Cool.
bigger tower and you want a 3D print, there's that.
You got a scale on that? Is that like 10
Yeah,
feet tall?
they
or-
come they come in different sizes. You know, you could scale it however you want to, but
Wow.
you can see
Looks
they
like
have.
strip mining size.
Oh
Yeah.
yeah. Well, but you know, is you can't put a Lego insert into the reel, so that's why I'm like, going. It's useful for that reason that you can put your insert there, or yeah, or the 3 meter or whatever, that type of.
Yeah, I think what this is it's a model of an
If you look on
excavator
the
tire.
inside there, you can see that similar to some others, but
Yeah.
the key is you have the outside that you can wrap around. So I thought that was interesting for outdoors. That yeah, you can see. So that's the first thing, and then let's see, where's number 2? And then the other thing was let's see, was this one. So there's this one, and what caught my eye was the fact that it's very elaborate, but buried down in there is these cheap motors. So you'll notice, and it has the battery, and so yeah, but it's a little different than the normal layout because of that center there. So yeah, let's. Unfortunately, I don't have a video of it. I wish they did because it would be interesting to see how well it really works. But it looks like they have it broken down in detail.
Could you tell how it's articulated in the center there?
Not really. That's why I was trying to figure out
Yeah.
based on that. It looks like, yeah, I really can't tell what that piece really is because, unless that's that piece right there, whatever that is. So I assume it's something they can bend, but
Or maybe
So-
it just swivels in the middle. and-
yeah, and it may shrivel. That's what I'm thinking. But it's right there, that piece. So I'm
Okay.
thinking, yeah, it shrivels. I don't know what our is, but yeah, I mean that's how it looks there.
The wheels are powered, so this is not. There's no power. It's not a power shaft or anything.
No,
So,
I
and it's
don't know
got
what that does, but
it's
yeah,
got bearings.
Yeah, that's unusual.
Trying to
Looks to me
figure.
like it's just a suspension, right? I mean,
maybe if we go up and down, yeah, it could be that.
Just so that-
Well, I think what it's allowing it's allowing the front and the back
Raise and
to
lower.
twist relative to each other along a single axis.
When I was in the
Yeah.
National Guard, when I was in the National Guard, I operated a forklift, an all-terrain forklift that did
Yeah.
that. That it would the
So,
front and
yeah,
back were like that.
So that way it can rotate.
Okay.
Yeah.
Go 2 more pictures, John.
Go 2 more.
So I've thought about
One more,
taking this
one more.
approach
One more.
for the mechanical wheel robot to keep all 4 on the ground at all times, but you can imagine that.
So yeah, that car
Yep.
may work for you.
Well,
having
but
that design.
so the challenge now is going to be how do you get that joint to be stiff enough so that it doesn't like.
Well, it rotates. I'm thinking,
Well,
it
if it's
basically
going to
rotates
rotate
on
this way,
axis.
but just look at it from that view, right? So what's going to keep? Oh, if you go back, yeah,
Yeah, right there is the best
yeah. So
sort of layout of it.
what's going to keep the front and the front from rotating left or
Well, you
swinging?
see there.
Well,
This
yeah, there's
part
another
can
axle.
go up and down, and this part can go sideways. Yeah. So yeah, when I look at that, yeah, effectively this can go sideways and this can go, this, yeah, this can go sideways.
It's kind of like a universal joint, but you're
Right.
right, Carl, that would not work for a Mecanum robot.
It wouldn't?
No.
Why?
Mecanum requires
All four
attention
wheels to
between the wheels. So basically, it relies on alignment coming from the frame between the four wheels. And what Carl wants is just the ability of the fourth wheel, if you're on an uneven surface, to come down and contact the ground.
Right. Well, they all need to be independent, basically.
But I would have thought
Mecanum and suspension does not work so well.
My concern actually is that how do you make a joint like that stiff enough that it doesn't rotate? Because those you want basically have a fixed front axle and a fixed rear axle, right? Because the wheels on the front or the back don't move relative to each other. They nominally, I guess, would be in a straight line. So, but then like just in this plane, like if you imagine the left-hand side being fixed, but if you put your hand on the Arduino and you push up or down, unless that pipe that goes left to right is super stiff with really good joints, then you're going to have a lot of play in side-to-side play on those axles and those wheels. That's the part that concerns me, Kareem. So, because I would have thought that the Mecanums could tolerate a little bit of non-planarness if the center joints are all stiff.
Well, that's just what I was saying is that you can't have like a side-to-side motion. You could have the rotational motion looking from the point of like in front of the robot. That might be okay as long as the axles that imaginarily connect the Mecanums can't go out of orthogonal to each other.
Right. Yeah. Okay. We're on the same page.
Yeah. In the overhead view. Yeah. They need to remain orthogonal.
Because I think I've actually seen a Mecanum wheel that has this approach, but yeah, how to control it mechanically? It's
the ultimate problem with Mecanums that I've always come back to is that even if you had that adaptability, they are inherently designed for situations where all four wheels have roughly an even amount of gription on the surface, if you like. That's basically what it relies on to work properly. And in an outdoor circumstance where you got things like grass and patches of gravel and dirt and all that other stuff, it's never going to work right.
Or the weight distribution, or maybe that's part of grip.
Yeah, you still have to. Yeah, exactly. You still have to have an approximately even weight distribution across all of the four wheels.
Yeah, that's cool. So, John, you're going to start building or still finding?
On that one, probably, actually that looks interesting from the angle. I didn't realize just how it moved the wheels. So I may build that instead. I was work on the assist wheel version that I had shown back several weeks back that used those cheap motors. So, sort of the Mars version. But this one actually has that tread and it drops down to only 4 versus the 6. So I may switch gears. But we'll see. In the meantime, if I find anything that will fit your wheels, I'll definitely holler on that. But
cool. I have something tangential I can throw in. So we were talking earlier about, and I think Michael, you were asking or commenting on just Googling and finding code to use that you can drop and play. So that reminded me of this that came out a couple days ago, or I guess just yesterday. So there's this thing, Harold has mentioned it before, but it's a GitHub Copilot, where you somehow just kind of describe in words what you want the code to do, and CodePilot will then go scrape from its AI wonderfulness and assemble some code that you can then code fragments you're supposed to be able to pull and drop in and run with. And I've not played with it, but I think Harold has or can mention about it. But anyhow, this article is talking about how some people have been playing with it and have determined that when they ask for the right thing, what they see is that it's regurgitating uh, uh, without any copyrighted attribution or anything. It's regurgitating what looks an awfully lot like code that the author wrote to begin with. So in fact, it looks like this Copilot thing is it's not only scraping public repositories, but it's learning and scraping private repositories. And then when it gives you this royalty-free, okay to use code, it turns out that, well, is it really?
You've talked about that before, but you've never messed with it much.
I have not tried it, but it looks interesting to me.
You
It's the latest in a long line of, yeah, this software is going to put software engineers out of business. But
yeah. Well, does GitHub have anything like that? Search engine. I mean, I've never messed with GitHub much as far as from a user's point of view, except somebody will point to it, on a web page or something, or in YouTube. But I was wondering if, because there's code all over that GitHub's. That's why they put it on there. So, anybody know anything about that? Nope. Okay.
You still end up having to search for it.
It's just a library and a search engine, right?
Well, I'm good. I'm good with that. Yeah, it's got a search engine in it. That does. Yeah. I've just never messed with it. GitHub.
So. Nose around. Try a few things and
yeah.
All my robot teams use GitHub exclusively for hosting their own repos, right? And many of the repos that they rely on are also hosted on GitHub, just because it happens to be the predominant host of open source code. I would say still. So there's a lot of goodness to be found there, but you always got to be aware. And it is possible to trample on copyright. Sometimes people post things that are copyright, but and they're not aware that they're like public, and that can happen too.
Yeah.
I'd like to ask John Gather. How do you say your last name? Gather?
Go check.
Yeah.
How do you say it?
Nothing like it's spelled.
Well, that's kind of the opposite of me. Nobody spells my last name the way it really is. My last name is Iverson, and they always spell it Iverson. So it's just the opposite. Anyway, I just want to ask you about your skull. In what context are you putting that? Like on your front porch or for Halloween?
It's a Halloween prop. I'm going to put two of them, different versions of the skull face with different capabilities, side by side. Matter of fact, I tested it just yesterday. I put it out in front of my front door, and I was testing the lighting conditions to make sure that somebody who's walking up the sidewalk, there's enough light where it'll actually detect the faces and then activate them and start tracking the faces with the eyes.
Yeah, that'd be good.
Let's know how successful it is once Halloween comes around.
Yeah, you gonna video any of that? Any of the action outside your house?
I'm gonna try to. I'm gonna be handing out candy too, so we'll see.
Are you going to bring out the spider this year, or is he kind of retired now?
Well, I made some modifications to the spider that I wasn't real happy with, and the glove's not the glove's not working too well because it's the flex sensors in the glove. We have these really weird contacts that has a difficult time getting them to stay connected. And I keep getting open circuits in the glove. And at some point, I just decided, nah, I'm not going to mess with it anymore.
Well,
I might get back to it at some point and eliminate the glove and just have it do pre-programmed motions based on maybe a passive infrared sensor. When somebody walks up, have it do something.
Yeah, when some little kid, you have one certain height so that when he passes by it, it's a little kid. You can have the spotter just kind of drop down on it. The kid would never come by your house again forever. Yeah. In fact,
Well, I was wondering if anybody else will get into building Halloween projects, things like, spooky stuff that follows them around, and,
yeah.
I mean, I may take these skull faces and eventually I've got this thought that if I can either find, well, my 3D printer is not big enough to print the skeleton because some of the bones are just too long. But if I can find an off the shelf skeleton and maybe put some actuators in there where not only when you get close to it does it scream, but it also throws up its arms.
Yeah. I like that.
Kicks you. Kicks you in the shins, maybe.
Or maybe when you get close to it, it raises the arm and just points at you like this,
If you make it scary enough,
and have the hand follow them, not just the eyes, have the hand follow them as well.
Yeah, I saw an interesting little Halloween project off of Instructables where they used a those little LED tea candles. I'm sure you're all familiar with. You go into, you can buy 12 of them for a couple bucks. Well, I guess they take the lens off of it. The one that looks like a big flame. They take that off, and they kind of like paint the front of it so that it looks like an eye. So, and then they hang it from a piece of like a fishing line. So they have these arrays, if you can think of it, arrays of blinking eyes that, kind of look like they're out there in out in the, by themselves. It looked pretty good. It looks simple and pretty easy to do. Yeah, I tell you what, if you like Halloween stuff, this time of year at Instructables, that's about all I got. I mean, it's amazing. If you made cakes and stuff like that, boy, there's some really pretty weird stuff out there.
Yeah, John, after Halloween, you could use it as a theft deterrent device. Somebody comes up on your porch and the skeleton starts,
Yeah, I was gonna say if he makes it scary enough, he'll never have to give away any candy.
Yeah.
Well, I am a little concerned with. I have to be careful how I place it because if there are multiple kids lining up and the one closest to it gets scared, I want to make sure that if they turn to run, that they don't knock another kid into the wall. So I think I'll set up to where if they do knock somebody over, they'll just fall into the hedges.
Yeah. Yeah.
Very nice. Okay, guys. So where are we? Any other?
Well, I found another thing might be of interest, so I'll show you this one. So there's a real mini vacuum robot you can 3D print build, and it uses the cheap motors to boot there.
My favorite.
So that's why it caught my eye. That's why I'm like, ooh, the nice cheap motors.
So how mini is mini?
Well, those motors are not that big. I'm thinking that is going to be small.
So the fans just blow the dirt on the electronics, and then you've got to clean it off, maybe.
Yeah, I was going to say it's not going to be very big because those motors aren't that big.
Yeah.
Do they have anything really running, showing everything? Let's see, their parts. Ooh, play. Let's see, what does he have going there? Okay. Okay. Well, they're seemingly can bounce based on that.
Maybe that's the carpet height adjustment, maybe.
Oh, that could be it. That's a thought.
I mean,
That's
carpet,
nice.
or maybe that's about the right size to do upholstery in a car, maybe, but
It's pretty small.
I was gonna say it's small based on the motors.
Yeah, it doesn't appear to have a brush of any kind. It's just using pure suction.
All right. Yeah. Yeah, right there is the two motors. So yeah,
Both ends, yeah.
Looking at the 3D parts, though, somebody spent a lot of time.
I'm all in it. Yeah. So there's
It
the client.
sucks though.
What?
nailed
Didn't
it.
hear what you said.
He said it sucks though.
Yeah,
Oh, yeah.
That's all it counts.
that's great.
Yeah, that's a good thing.
I mean, there's the little hole, and there's the bumper.
What about those two little green
I
things are
don't
the bottom?
know.
Maybe they're the brushes.
Could be.
Man, those are the smallest brushes if that's the case.
No, I think those are the inputs to the
Oh,
fan.
okay.
Yeah, so you got one. Yeah, that's why they're staggered. One's forward and one's back because they have to face each other.
Okay, so what is that roller supposed to do? The like
I
purple
think
roller?
that's the battery. I don't
Oh,
think
that's
it's
a
a roller.
battery.
That's a
That's the
battery.
battery.
Fooled me.
That's a 18650.
18650, yeah.
Right,
Yeah.
see, there's the case.
God, that thing runs on one battery.
Okay, I'm sorry. This falls in my way silly category. Way too silly.
Hey,
Yeah.
but it may work. I'm thinking, actually,
You know how
could
many
be.
passes that would have to take to clean a room?
Well,
Okay.
I mean, that thing's like 4 inches across or something. It's
That's-
tiny.
Yeah.
That's
I
what I'm
think it's
thinking.
just-
Maybe car upholstery, and it'll get your car done in an hour. But
Did you get carpet in the car? Yes.
I think it's supposed to be a desk toy myself.
Well, yeah.
It's
what
for
it
cleaning
does.
out your hamster cage.
oh yeah, that would never clog.
Yeah, that would be. Where they don't. It's not clear how they even have a hamper. So
Well,
once it
that's what
fills
I'm
up,
trying to figure out. Partially, I'm thinking, okay, I think
You mean a
that-
hopper?
yeah.
Yeah.
I th-
That's what I said. The dust just blows all over the electronics and you gotta
There goes the
get it
hamster
off
cage
somehow
cleaning.
afterwards.
Do they have a video of it running?
No,
Yeah.
unfortunately not. Okay, I think it goes in there. I guess you have a filter there. So yeah,
Maybe, yeah.
in front of the. Of
And then
the board,
it's
it
easy,
has
6
that.
screws, and you can empty it.
Yeah, well, 4. I think there's 4 on the top, but I think somewhere they have. Yeah, maybe 2 actually. It looks like one there, one there, 2 screws.
But I mean, all of the work that was done on it, it makes me wonder if this was a school project or something.
I don't know, but it
I
is
mean,
pretty.
there's a lot of work done on that.
So
So,
the nice
it
embossing
definitely
in
did
there.
modeling.
Yeah, so it shouldn't.
Well, yeah, he has other designs.
And you can use it to remove moles.
Mhm.
Yeah, that's,
So actually, this
Right
might be
off.
more cute to make. I'm thinking, especially for when we have the nest contest, it could vacuum the clean the floor as you do the contest. But yeah, as I say, it's nice and small, and it uses those cheap mortars. So I don't know
Cool.
what the board there is. Looks like an H-bridge mortar bore, but
I think it's either an 8266 board or an ESP32 board. That's what it looks like.
there because they don't really describe
Yeah.
that.
so I think next in queue we have some RTK stuff.
Ooh,
So
from who?
Kareem.
Yeah, that's me.
Okay.
Let's see if I can. it's going to actually sound a little bit more like an advertisement than anything. So I was down in South Padre last week, and I set up a base station down there to try and do stuff on the beach. And the robot wasn't cooperating, but I did get the base station set up. One of the problems you have with the base station is getting the initial fix for it, especially if there's no local data available. The typical way that you do that is you put it into something called survey in mode, and it basically you tell it what precision you want and how long it should take. And it basically just samples the GPS readings, and it finds the average over that time period and sort of figures out where its centroid is and what the nominal accuracy is. And the problem with that is that you don't always get the accuracy you want. So I was looking for another way to get the accuracy. One way to get the accuracy is use it as a GPS RTK rover, assuming you had a signal available, right? But if you had a signal available, you wouldn't need the base. You wouldn't need to set up your own base station. And so I was looking around, and so one of the things I found was from uBlocks, a service that they've had for a while called Point Perfect. And I just wanted to share some details about that. So I'm not finding my browser on it, but basically, if you search uBlocks Point Perfect, you'll find that they have a location service as an Internet of Things type service. And if you go down the rabbit hole in the pricing, it turns out that for 60 hours per month of reception, you can get their internet-based version of an RTK base station effectively for $4 a month. And so I found that incredibly reasonable. Now, so in other words, they have two different ways of handing you that data. One is to requires you to have an internet connection, right? And then you're going to use basically that internet connection to get access to their RTK network of correction services. Now, unlike other I usually use RTK to go, but then I have to publish my own base station if a local one isn't available, and I can get down to that 2 centimeters of resolution roughly. With the uBlock service, they only advertise 4 to 6 centimeters of accuracy. So if that's not good enough for you, then I guess you wouldn't want to go in this direction. But that might help Doug out a little bit. But you still got to pair that with a like an F9P. You still got to have on your rover a GPS RTK solver, right? But the point here is that. So I kept looking up at Farmersville and seeing if there was last year there was a service, there was a base station that was appearing every once in a while in RTK to go, and I actually saw it down in South Padre last week. It was still there, and I looked today and it's not there anymore, right? It was in Princeton, Texas, and so that one's just not reliable. But I did end up successfully using Point Perfect, so I paid $4 to get a month worth of service, and all I was using it for was to get a fix for my base station. So at that point, I knew my base station was within 6 centimeters of the solution that it gave me, and that would have been plenty of accuracy for the stuff that I was going to do out on the beach had the robot itself been working.
So what's the link between the service and your rover? Is it Wi-Fi?
Yeah, you're still responsible for getting your rover, your robot, to talk to the internet and access their service, right? And on top of that, I think it was, I don't remember which message queuing service it was using, but it was one that a lot of people use. And they also have sample code there in Python for decoding their signal and feeding that correction data to your GPS receiver.
Oh, okay.
So I think it would be, pretty easy for a lot of y'all to use it if you wanted to go that route. Again, you still have to have like an F9P or something similar as your receiver on your robot in order to make use of it, but you're going to get a highly accurate signal, and now you're connected to a professional grade network for that limited amount of money. It's going to go up. The price is going to go up if you use more than 60 hours. And they have another way of delivering it to you. So if you're way out in the boonies and you cannot get an internet connection, but you have an additional sort of receiver on your robot that can capture L-band correction signals, you'll get it directly from the satellites. But the cost there goes up by another like $40 a month. So but that completely severs your reliability on landline connections or some other way of getting to the internet. There you're getting your corrections and your and your primary signals both from the GPS network. And they also sell, so you can get receiver boards that have that already integrated L-band correction signal reception. And you can also buy a separate module that Ublox offers that will just focus on adding the correction data.
Yeah.
Again, more money. Yep, exactly.
Probably several $100s.
I actually haven't even looked into it yet, so I'd love to know if anybody figures that one out. But I wouldn't surprise me. Anyhow, I just wanted to share that because that's an option for anybody who was going to be at the Robo.
Well, this year for sure, I'm not going to be using RTK.
Me neither.
Yeah, because I'm really going after. I'd like to have
the robust cone.
I'd like, if I could get it robust enough, I might even, compete up in Seattle. That would, it's going to have to be a little bit further than what I'm going to have this year, but that could be close enough where I could get there. The real answer, is to put some sort of filter on the GPS value so that, like if it's moving around from its, the filter essentially doesn't, if the point suddenly says that you moved 20 feet, you know enough to say, no, didn't really do that. If you're not moving towards it, you know what I'm trying to say?
Sure. Yeah, you're trying to reduce the amount of random jump around.
Right.
With the filter. That still won't guarantee your accuracy is going up.
But like I say, in a way, this is sort of, as at least as I see it now, and I might be proven wrong, this is not a far away problem. Okay, this is a close up problem. Otherwise, the closer you get to where you want to go, the bigger problem it is. So the trick is if you can find the cones from 40 feet out, I don't think it's a big deal. You know what I'm saying?
Or 20 feet.
Or even 20 feet. Yeah. I mean, when I was running it in my backyard just over and over and over again, I had several direct hits, where it just poop and hit it. But then I had other ones where, it obviously had shifted because I actually had some where it would go around in a circle, where it couldn't turn down to get to where it wanted to go. And then you saw the one I showed where it went up around the cone, switched around, and all of a sudden it went way down in the other thing, and it came back and went back up to the cone again. And all of that is, it's like
Can't
I say,
tight enough. Huh?
So now I'm curious, right now I'm sampling the GPS 5 times a second. This GPS unit is capable of going 20 times a second. Okay, I mean, I could really turn it, but I'm not sure I really see the need for that right now. And I'm curious I'm curious though, maybe Kareem, you could have, if you're taking more GPS measurements, is that just,
It's not gonna, so so it depends a lot on the receiver and what kind of fix you've got, right? So
yeah,
in the GPS realm, in the RTK realm, there are there are sort of different stages before you get to RTK fixed,
mhm,
right? There's also one called float. And
Float,
what
yeah.
you'll notice with float, which again doesn't apply to normal GPS receivers,
mhm,
but some normal GPS receivers will sort of see this behavior. In float mode, what you'll see is that the the subsequent fixes feel like they're on a line, right? In other words, they're more closely related to previous fixes,
yeah,
as opposed to just stochastically jumping around all over the place.
right,
Um, and so you could argue from that increasing your sampling rate might be helpful, um, even though you're probably still averaging them or something like that, and you might feel like you've got a better fix. I don't know that there's data that supports that thesis. I think with a normal GPS receiver, um, again, I think if filtering out the outliers is probably your best bet, which you already sort of implied.
mhm,
um, I don't know that averaging them will necessarily give you something better. I don't think you need a I don't think you need a high um, refresh rate
Not unless you're going
when
really
you're
fast.
unless you're going really fast. Yeah.
Yeah.
right,
In my case, if when I'm getting a really good signal down at 2 centimeters, then going at a medium speed, I'll at times consider going up to 10 hertz. But normally I'm at 5 hertz. But 5 hertz seems high to me for a normal GPS receiver. Again, unless you're going very fast, but walking
mhm,
speeds, it doesn't seem to make a whole lot of sense.
yeah,
I cert, in other words, I certainly wouldn't advocate going any faster than that,
yeah, yeah,
unless you have some magical capability of analyzing all of your, most recent 20 samples and getting a better data point out of that.
yeah,
Yeah, I can't see how you could do that though. I mean,
I don't see it either.
you're
Yeah.
moving and you have uncertainty on each point you move to, and
well,
Yeah.
you might be able to pull a signal out. I'm not saying you could. Have to think about this more, but you might be able to pull a signal out of the fact. Remember, you're measuring distance.
Well, I think
Okay,
that your
and
GPS
so
receiver has already done that. It's pulled as much sample out as it can
yeah,
for the data it has, and that's why you have to go to something like RTK, where you're actually looking at correction signals to get any better
yeah,
statistically.
yeah. And if I thought that I could minimize, it's also possible, to use. Like I say, I do have an encoder and I do have a steering angle, but I'll be quite honest. There's so much bouncing around in the grass that the steering angle, it might as well be a what do you call it, a bang bang, because
Right.
it's you're going kunk, 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 kunk across the grass, and
Well, your IMU might be a better indication of your most recent sort of heading,
yeah,
and than either the GPS or your output steering angle.
hmm, yeah, you could, yeah,
In my case, they're pretty balanced. So I typically use the IMU for my heading, even though I can infer the heading from my GPS pretty fast.
hmm,
Um, but they're sort of like running neck and neck, right?
yeah,
But if you don't have a highly accurate GPS signal, then I would definitely be relying on the IMU
hmm,
or some other methods to generate heading, because that can go all over the place with a normal from reading to reading on a typical consumer grade GPS signal.
yeah. Well, anyway, we're gonna see how it goes. I've got to figure out how to practice more. I can't do in my yard. I'm doing all these what I call preliminary tests, but I really need to go out down to a park or someplace and really stretch it out.
Do a drive by at Steve's place. See what the color of the grass looks like.
And don't tell anybody else.
That's right. Just me.
Tell them it's all lush green.
Yeah.
Yep. No orange anywhere.
It looks
Actually, I
like you're
thought
making
about
a lot
doing
of
that.
progress.
Drive
I
over
am,
and use the
I am
neighborhood.
really pleased with this Oak Delight. I think it potentially overcomes a lot of the problems of trying to do it with a blob detector.
Mm.
And like I say, guys, all that stuff's out there if you want to try it. It's
You're bleeding edge right now, Doug.
I don't know about bleeding. I'm bleeding. Yeah. We'll see. Yeah. Boy, it just amazes me how progress gets made in starts and fits. Like today. So, okay, I wanted to make my goal for today was to get my safety switch working. So, I start off with a test program. That went pretty quick. Was able to borrow some code from the web and kind of get some ideas because it's not like you're solving. The thing I had to get was how to measure a pulse. Okay. And so setting up, getting that piece of information in a way that would fit well on the Teensy, because I wanted to do it with an interrupt, and I wasn't real sure how the interrupts on the Teensy worked. So, but anyway, it turned out not to be too bad, and I learned some things that I wasn't aware of because they were using ARM features that aren't part of well, they're part of Teensy because Teensy is an ARM, but they're not part of the Arduino framework. Constants and stuff like that I found out about that was able to make it easier. So anyway, so I feel pretty good about getting, I did accomplish my goal today. I just finished before the meeting, put in that code, and it was well tested out. So a win for the team. So tomorrow it's serial port day. So, and the thing is, I think I've got the serial port information ready for the Raspberry part. It took me a while. It turns out you got on the Raspberry, or at least I think this is true because it seemed to work after I did it. You have to disconnect the Bluetooth on the Raspberry Pi for you to use the serial port. I didn't realize that. And it's not hard to do once you know how to do it, but it's, one of those things like, well, why is it not working? Until you meet enough resources to find it. So
is
anyway,
it overlapping pin functions or something, or
no, okay. And now this is a very fuzzy definition, so don't take this as the Gospel of John. What you got is they have two USB they have two serial modules. One of them actually the baud rate will go up and down based on the clock speed or something. So it's not probably the one you want to. It's probably not the one you want to use. The other one is by default used by Bluetooth. So you go into Raspicom and you adjust the. I want to use the serial port. Well, that's all good and all well and good, but that's not the whole story because it's already being used by something else. So you have to go into the configure.txt and turn off the Bluetooth. And then it seemed like it worked. So anyway, so like I say, I'm working on that one. Tomorrow, serial port. So we'll see how it goes. How are you doing, Ray?
not doing too bad. Yeah, it's kind of the thing of I wanted to add battery voltage sensing to my little handheld thing, and looking up the functions in RoboClaw and how to do that. There were no examples, and I'm like, okay, how am I supposed to use this code? And figured it out, and I have to modify the code on the robot and on this little handheld thing because the structures have to be the same. Otherwise, if I send a structure defined differently from one end to the other, it's not going to know
what it is.
Not going to match it up.
Yeah.
Anyway, so I got that now, so I don't have to drag out a meter to try to find out, is my battery getting low, and because it's just on the screen now. So that's pretty good.
Yeah.
But yeah, I think I'm a generation or two behind you. I was.
Well, you were shooting. You were going to the cone, so you got that part done.
Yeah.
How come you not use RTK though? I didn't understand why you said you weren't.
Oh well, it's just kind of another complication, and it seems to get close enough to the waypoints that and I pretty much look for the cone. If I don't see it, I rotate a little and and look again, basically. So I keep rotating until I see the cone. So pretty much no matter where I end up with respect to the cone, if I'm in front of it or behind it, I should eventually see it. It may not be the fastest, but yeah. So I wasn't like using the Pixie Cam or the OpenMV H7 to say, okay, do you cruise along on GPS? Do you happen to see the cone with the camera? It's I get to the waypoint and then start looking for the cone. So, but it just seemed accurate enough, and just didn't want to bite off more than I could chew at this point.
Is it working? Is your way working? Right?
What?
Ray, is your way working?
It finds gets up to where the cone is and finds the cone.
So you use GPS to get in that area, and then you just hunt for it with your Pixie Cam.
Yeah, that's the we're given 3 GPS points, right? The targets for where the cones are. So I was just gonna head in that general direction, and then once I got to where I thought the waypoint was, within a meter of it, that's my my circle that's kind of close enough. Then I start looking for the cone, and hopefully I will find it. So but I still have to incorporate the only obstacle avoidance thing I have is a bumper in the front, 2 switches. And I'm moving pretty slow at this point. So I've also got if speed is if you hit all 3 cones, then speed is the next measure of how good you can do.
As long as you get a coffee cup, it doesn't matter though, right?
Depends on your goals. If you want to, if your goal is a coffee cup, then
Yeah. Well, I'm finding that's I probably need to do some adjustments to my bumper. It turns out that when it hits a cone, the bumper's not necessarily, the springs are too stiff and too stiff for that to trick. But I hesitate to reduce the springs because, well, anyway,
it also acts as a bumper.
Yeah. I the other day, even though I was driving it, I mean, I hit a fence pretty good.
Oh, you did?
Yeah, I broke some parts, and I had to spend that night, reprinting some parts to put it back together again.
Yep.
So,
yeah, yours looks like it moves pretty fast. I was gonna have the speed be kind of variable to the waypoint, go faster until I get like a certain distance away, 2 meters.
Me too. Well, I wasn't going to go there. I wasn't even going to be further than that.
Oh, you were really?
Yeah, I was thinking like from 100 yards to 20 feet is one speed, and 20 feet to 5 feet is another speed, and then the final 5 feet is another. But I'm probably going to do it is when you see the cone on your, okay, I now found the cone. that's going to probably be a creep,
Mm-hmm.
you know, and so it could catch the cone from pretty far out.
Yeah.
And, you know, I just, I tell you what, I'm really concerned, you know, is if we have to shoot a narrow alley, okay,
Mm-hmm.
That might be a bigger problem. You know, that could be a problem. We'll see. Anyway, I'm just curious.
Yeah.
Till next week, guys. We'll see if we got more. All right. I think it's time. Adios, dudes.
We'll see
You're
you.
on.